You can read that abstract there and see what it's all about, or you can just listen to me tell you about it and try to decode some of this stuff that we see here. We can also let Brendan talk about it if he can decode some of it. Basically, Tiffany Taylor of the University of Reading in England basically deleted a gene that controls flagella growth. And what that did was it removed the tiny tails of this soil bacteria. And so these bacteria rely on this tail so that they can obtain food, and it increases their survival rate. Well, about 96 hours after placing them in a low food environment in which they could not move around much due to the lack of that tail, those bacteria were once again growing flagella. So how did they manage such an amazing feat? Well, two mutations occurred. One in regulatory genes that control the levels of protein in the nitrogen uptake, and the other one turned the protein's job into flagella production control, which basically means, long story short, is that natural selection rewired the genetic networks, these mutations, so this very important feature that these bacteria have was basically evolved back, if that makes any sense. Oh, wow, what layman's term. So basically it came back. They re-evolved. There we go. They re-evolved the ability to create those tails. So with that being said,
Well,
we're going to turn it over to... Oh.
Sorry, I just want to. I was wanting to jump in with a correlation, actually. There's actually a specific type of cavefish that has basically evolved out the need for eyes because they live in pure darkness. Well, what they did was they took these fish and they actually transported them to an area with more light, and they actually started to grow their eyes back and start to use them. So this is actually seen in the natural world as well.